Here we have two new words. We have the word ligand, and we have the term complex. When you hear the word complex, what is the first thing that comes to mind?
Chemistry.
Chemistry? In my mind, the truth is this, probably. For girls, it's a boy's mind is complex because they can't understand us. And for guys, for boys, it's the other way around because we can't understand girls. Complex is something that is difficult. Okay? Now, here, we're not speaking about difficulty. Here, we're speaking about something that is not normal, not usual. So normally, a compound is something that contains a few atoms at most. Okay? But here, it's something more. And it's an interaction between a central metal atom or ion and a ligand via coordinate bonds. Instead of coordinate bonds, could I have written dative bonding?
مش dative covalent.
This is higher. Because dative, covalent, and coordinates, they're the same thing. Okay? Because they are the same word, you can interchange them. So up till now, last week, I think, we've seen aluminum in water, where the water was surrounding the Al3+. That is a type of a complex ion. Okay? But we're going to be seeing these a lot more in the coming days and weeks. Okay? So today, kif għaddilkom, I would like to do the naming. Naming is not that difficult, but it's a bit of a hassle. You need to practice pretty much. And I will be giving you some naming questions. In the naming questions, you have to input them online. I will probably do it via a Google Sheet. Okay? So from now on, from this week on, I will be giving you questions, okay, and homework, and the homework you input in a Google Sheet. Meaning, it's not gonna be difficult homework, but at least I can see what you're doing. A coordinate bond and the dative bond, they are the same thing, okay? It's just that they are different words, okay? Jisik it-tajt mitraħ u saqqu bil-Malti. L-istess meaning ma' kelma differenti. Okay? Now, here, what's more important is the term ligand. Għad smajtu biha il-kelma ligand?
Yes.
In biology.
Yes, biology.
Okay. And what do you understand by the term ligand in biology?
I don't.
Dennis.
Illa kienu just għalunna li tfisser chemical, like ek.
Okay.
Chemical.
Okay. A molecule or ion that can donate a pair of electrons to a central metal atom or ion. So, pretty much, ligands are nucleophiles. Okay? But, do you remember, have you done a thermal lesson 2 yet?
شنو؟ الشيش
SN1 u SN2. Did you do?
Just mentioned them. Like ما تخلنيش فيهم iktar tard nagħmluhom.
Okay. So you haven't done nucleophiles then?
La semmejnihom ftit.
Tomato of tea. Okay. Mela.
Positive charge kontra tal-electrophile.
Electrophile is positive charge. Nucleophile is negative charge.
Bil-kontra, sorry.
Okay. Yes, tal-copper u ammonia, it is a complex. Okay. Now, so pretty much ligands are either molecules that have available lone pairs or ions that have a negative charge. You can never have a ligand that has a positive charge. Now, if you were to look at the one I've given you yesterday, the names of some common ligands, you can see that you have ligands that are neutral, such as NH3, H2O, NO, CO, O2, N2, pyridine, and ethylene-diamine. You have ligands which are -1, and we have ligands which are -2. Dawn kollox ħajkun importanti si tiktar il-qudiem illum stess. Okay? But have you understood the concept of what a ligand is? So a ligand is something that gives electrons and a complex. A complex is the interaction between ligands and the central metal ion. Okay, Sawnek?
Yeah. Jiġifieri, jekk tagħti elettron waħda biss ma tkunx ligand.
No, you need to give 2 electrons, because remember, we are doing a coordinate or a dative bond. So to do and to prepare a coordinate or a dative bond, you need to give how many electrons, Carl?
2.
2. Okay? So otherwise, you're not making a coordinate bond, so you can only give 2 electrons. Apart from this, in any mechanism, apart from free radical mechanisms, okay? So pretty much all mechanisms in the world, apart from free radical, you will always transfer 2 electrons. Always. Any interaction will transfer 2 electrons. Now, ligands can never be positive, because for a positive molecule or for a positive ion, it shows that it has lack of electrons. If you lack electrons, can you give more electrons? No. Because if you lack electrons, you don't have any electrons to give. Now, ligands can be monodentate or bidentate, and this can therefore conclude tridentate, tetradentate, or multidentate. Okay? Chief is mono, bi, tri, etc. X'tifmu bila kelma mono?
One, no, like
One.
ħaġa waħda.
Yes. Mono is 1. Bi would be 2. Tri would be 3. Now, for A level, you have mono, bi, multi, and then there's one example. Li fil-fatt ma ktibtulkom hawnhekk. Għarrum bat niksbuh u nagħmlu l-koper. Ħalli tibqu tidraw ftit. Dik huwa tetra. Okay? For now, make sure that you know the ones I've given you in the table. They are not the only ones. And for homework, I'm gonna give you one which is not in that list. So you can see that you can actually look things up. But it will not be a problem. Now, monodentate, a ligand that can only donate one pair of electrons. Bidentate, a ligand that can donate how many pairs of electrons?
Two.
Two. Okay? Issa, I'm gonna draw a couple of complexes. Okay? On the board. I'm going to start with the simple complexes where all the surrounding atoms are the same. And we're going to try and start doing a little bit of naming. By today afternoon, I'm going to send you the notes with respect to everything we've done for aluminium and transition metals up till now. The notes might actually have all of the properties of transition metals. If there is something we haven't done, we'll be doing it next lesson. Okay? So we wouldn't have managed to do everything. Okay? But don't worry about writing these instructions. You can then copy them afterwards. With regards to videos, I haven't sent you the link to the last lesson, I think. No, I have. But videos are private. So I don't think anyone else can see them apart from you. As long as you don't give the links to other students, which I don't mind. I know you received an email from the school about the policy of not sharing videos from the lessons. As long as the links are coming from me, you can share them with whoever you want. Of course, don't take videos yourselves of the lesson because it won't make sense. And Kenneth and Jürgen, because I think this mainly suits you too. No editing of videos. Come on, quickly. Now, let's draw iron dissolved in water. So if it has six bonds, what shape will this complex be? If it has 6 bonds, what shape will this complex be?
Hexad or kelma.
Sorry?
Octahedral.
Octahedral.
Octahedral. Okay? So anything with 6 bonds and no lone pairs will be an octahedral. The same names you used to have for VSCPR will also be true here. Now, let's make this point. For VSCPR, you can work each and every compound. When it comes to complexes, you need to know the shape. Okay? I don't think we'll be doing it today. Next lesson, I'll give you further instructions how to know the shapes. Okay? Because next lesson, we'll do stereoisomerism. Okay? So you've done isomerism in organic chemistry. Here, we're going to be...
We've done stereoisomerism.
You've done?
Yes.
You've done isomerism. Yes, I know you've done that. You've done them in organic, but now we're going to be using them for an organic. We're going to be using cis trans, mainly cis trans, but there's another one, okay, that you might not have done. I will introduce it myself, okay? But
Lim jisir, għax għamilna ħafna stereoisomers, mafx.
have you done chirality? The mirror images?
Mirror images.
Semmejna
tal-cohort,
l-optical
mela.
isomer.
Semmejtu għawkoll?
Optical isomerism.
Iva minnihom.
ħafna drabi, that used to be mentioned in second year. But that is teacher
You
dependent.
did that.
It's very brilliant. So we're going to be using those two isomers, okay?
Alright.
Sir,
Hydride, because this has 6 bonds. So 6 bonds will be like that when you surround them around iron. Don't look at it as J. Kyra. Don't look at this as being planar. Remember, nothing is planar. If it has 6 bonds, the bonds have to be as far away from each other as possible, which means that they're going to be in a relative position. Tell me, Kyra.
għala ktibtu H2 on the right hand side tal-Fe3 plus.
As the oxygen is donating the electrons, right?
Just għamilta
So it has to be the oxygen next to the arrow and not the hydrogen.
Alright, thank you.
You could write it differently. You could write the H here. But if you're going to look these up, you will never find the H in front. Okay? So any picture you're gonna find online, and probably even in my notes, it won't be with the H in front of the oxygen there. So at least you get used to it. Julia, fimt għala octahedral?
Sera, daw complexes li għet impenġu bħalissa, xed impenġjom.
Yes, complexes.
Alright, thank you.
Sir,
Welcome. Għaraf nitkellem, Mattias?
hija, tista' terġa' tirrepetija tal-octahedral, please,
So,
għax ma fimtix.
in VSCPR, we used to speak about having the largest distance between the pairs of electrons, right? Not taqbel?
Hija,
Is it the valential electron pair repulsion theory? VSCPR. When you have 6 bonds, the furthest away they can be is in the shape of an octahedral. So it's the same theory as VSCPR. But this time round, we're just looking at the number of bonds. We will not be looking at the lone pairs pretty much. The reason being is that the lone pairs will be a differential. Okay?
okay. Hija,
And
thank you.
once we draw them like this, we draw them to D. Normally, we will draw these into D. Why into D? Because it's easier. They are 3D, so keep it in mind. Okay? But they are 3D structures. Now, do you realize that this is 3 plus and this is 2 plus? Okay? So, I'm going to name 2 different compounds here. These are not the same. One is IN3, the other one is IN2. So, when you want to name the complex, you start by writing the number of atoms. These are all monodentates. And most of the ligands we're going to be using will be monodentates. Okay? So this is hexa.
Repeat what you said, start by, għax tamel l-steps jena. Start by.
The steps, ħantihomkom sal-lejla. Ember.
Okay.
Okay? Because it's more important. I mean, I will be repeating these because they're useful, but it's more important to understand than to write.
لا قد نفهم تا ġifieri, just like
I know you understood, but I'm just telling you. It's more important to understand for today. Okay, start by writing the name of the ligands. So it's hexa, meaning 6, aqua, meaning water. Iron 3. And this would be hexa, aqua, iron 2. So simply by writing the number at the end, you are distinguishing between Fe3 plus and Fe2 plus. Okay? Not blue?
إيه
Apart from these, we could have been in a position where we have installed, instead of having H2O, which is neutral, you could have had Cn minus. So now all of this complex will be 3 minus. Why is it 3 minus? Because if you have Fe3 plus and you're adding 6 Cn minus, the 3 plus is going to be neutralized and it's going to be removed because 6 minus is bigger. Therefore, 3 plus minus 6 will be equal to the charge of the complex. So 3 plus minus 1 minus 1 minus 1 minus 1 minus 1 and minus 1.
So,
Which will end up, 1 second, Carl, being 3 minus overall. Tell me.
but how do you know that the charge for Cn is -1?
Oh, you need to know that. It's cyanide.
Okay.
That's something even in organic chemistry. Cyanide is something that's going to be very, very, very important. If you haven't done substitution reactions yet, then you're fine. But the cyanide ion is going to be crucial. Okay? Now, when we write, one second.
Okay.
When we write the Fe2 plus or Fe3 plus, you can write it in brackets or not. Because it's the charge of the central ion, sometimes it's the case that you don't write the overall brackets, okay? Because the charge of the central atom or central ion, you can keep it in the center, okay? Now, Claire, they're all not planar, but sometimes it's easier for us to draw them into D. Therefore, we draw them like this, when in reality, they are like this, okay? Remember, just because we used to draw something into D, for example, in organic chemistry, we draw a lot of compounds like this. Not blue doesn't mean they are 2D. In reality, they are 3D, but it's easier for us to draw them into D. Tell me, Shana. Tell me, Claire. You tell me, Haja.
Lele, thank you.
Tell me, Shana.
Ma fimx fej jitlu daw il-monodentate u l-bidentate. Ġifieri pereżempju l-ewwel waħda hexa kwa iron 3. Li ma tiġi.
Nitkellmu biss fuq monodentates. Okay?
Ġifieri daw monodentates kollha.
Yes, because each molecule is giving one pair of electrons.
Okay.
When I
Thank
give you an example with a bidentate, you see the difference. So, why is it 3 minus? So, Fe3 plus is 3 plus, right? Each Cn minus, each Cn is a -1. Mela, overall, they will cancel out. Cancel out and cancel out. And what you're left is with a 3 minus. Okay?
So what's the name of the ion? Hexacyan ion 3?
ما فهمتك شريك.
What's the name of the ion ġifiri of the complex ion?
Da jew
Tleta taħt, issa li għamil nis.
taħt issa. Ta' taħt hija hexa issa hawnhekk ħajħu da xejn differenti. Għalhekk qed dan eżempju għal issa, ħalli il ftit fuq eżempju oħrajn. Dan huwa hexa sajano. Imma peress li għandna negative charge, okay? Peress li għandna negative charge, mhux ħajibqa' għajn, ħajġi ferrate 3. Mela.
Understandable.
ħafna rridu distinzjoni bejn a complex that is a negative charge and a complex that is a positive charge. This distinction comes around with the naming or through the naming. Mela, if we have a positive complex, like the first one, we use the English name, ion 2 or ion 3. If we have the negative charge, we use the Latin name. So it's ferrate for ion. Tajtli, għanna ħakunu nafu in-namings kolla? No, but the most common ones you would need to know. So iron is ferrate, copper is cuprate, lead is plumate, and tin is tannate. Issa lead u tin mhumiex transition metals. Okay? But chromium is chromate and manganese is manganate. Okay? Now, the first one is a positive complex because water has no charge. The second one, each CN, each nitrile group, each cyano group, okay, is giving a negative charge. So each CN is giving a -1. What does it mean that it's giving a -1? That the Fe3 plus is receiving 6 negative charges. So if you start with +3 and you receive 6 negative charges, overall you will be 3 minus. Okay? Now the first one is a positive complex because we have Fe3 plus and each of the waters is not giving a charge. Each of the waters is neutral. Okay? Now, are you okay with these three?
Yeah, so far. Not bad.
What did you understand, Maya? I mean, why it's negative? Magnesium oxide is neutral. When we have magnesium oxide, okay, Mela, magnesium oxide is neutral because the 2 plus cancels out with the O2 minus. Okay? When we have this, it's not neutral because the 4 plus are not cancelling out exactly with the 2 minuses. So you end up having CO3 2 minus. So you're literally counting the positive charges and the negative charges. Okay? Issa. For the cyanide, for the hexacyanoferrate, you have Fe3 plus and 6 Cn minus. So the overall charge must be 3 minus. Exactly. Thank you, Carl. Xenia, normally I would say in an exam, it's better to draw the 3D structure, but always make sure to know what you're being asked. Because normally I will ask you for the shape of the complex, and for the shape of the complex, it has to be the 3D. Now, why I had a question. Why is it that Fe3 plus does not stop at 3Cn minus? It's because is-din ma tax bitlu fiha flow level normalment. But Fe3 plus is large enough to be surrounded by the ligands. Just because the ligands are negative, it's not going to tell them stop surrounding me. In fact, later on in the chapter, when we do iron and copper, we're going to do something which is called ligand exchange, where certain ligands are preferred over others. And there, yes, you might have situations where whatever is not being represented by a negative charge, you get as a neutral atom. But for now, assume that a complex, okay, will not stop when its charge is 0, but will stop when it's surrounded by enough groups. Okay? This has to do with the d orbitals being available. The sign of the orbitals ma titlux fihom fl-A level, just that they exist, not what they are, and not how they work.
ġifieri ser dejjem settar tkun hemm.
Ma midix ma għajbi. Għajat iktar.
Ġifieri dejjem settar tkun hemm groups.
No. The shapes and the number of atoms or groups surrounding the center metal ion, we're going to be doing it next lesson. Okay?
Sorry.
For now, we're
you.
just focusing on the name. But, yes, it's a situation where it's a fixed number. For iron, it's always 6. If you were to have platinum, it's always 4. For silver, it's always 2. Okay? But they are a fixed number. So, let me write a few complexes on the board. Now, instead of drawing them, we can write, not write, the complex, okay? Issa, kieku kien ħilletin, u ħadni qed jiena. U probabbilment anke intom. In organic chemistry, where do you actually write? How do you write them? you write everything in alphabetical order, right? Not blue. Same goes here. I will write 3 complexes and then we're going to name them. Now, as you might imagine, if you have a charge, you need to have a counter ion. So when you have a compound, it's not enough to just write the ion only. So what we did before, for example, hexaquaferrate, there's going to be, for example, hexaquaferrate chloride, okay? Which is FeCl3. And there, it's important to actually write the anion as well. Apart from this, the anions will tell you the charge of the complex. For example, let's look at the first complex. The charge of the complex is 3+, because it requires 3 Cl- to be neutralized. The charge of the second one is also 3+, because it requires 3 bromines. And the charge of the last one is 2+, because it requires 2 chlorines. Now, apart from that, then we will find the name, okay? And when we're finding the name of the complex, you need to find the charge of the parent, the central atom, right? Or ion. So in this case, it's chromium, platinum, and platinum. And the charges are like this: 3+, 4+, 4+. Now, how did I get to the charges? For the first one, where we have ammonia and water, both ligands are neutral. So both ligands have no charge. So the final charge here must be equal to the charge of the ion. So if there is no charge on the ligands, the charge of the complex is equal to the charge of the ion. If you have a Cl-, the negative charge will reduce the charge of the central ion. So if it's 3+ and you have a -1, then your platinum must have been +4. Again, if it's 2+, E-tynene diamine is neutral. Okay? From the chart I've given you. And Cl- is negative, but you have 2 negatives. That means that platinum must have been +4. So, to name these, okay, you need to realize you have the amine group and the aqua group. Now, for the amine group, it is higher priority because it is first in alphabetical order. So no, the charge of the complex is equal to the charge of the central ion when the ligands have zero charge. This is a little bit of algebra here. So let's do the platinum one. Pt minus 1 equals plus 3. Therefore, Pt or platinum equals plus 4. Okay? For this one, platinum minus 1 times 2 equals plus 2. Platinum equals 2 plus 2.
Jiġifieri għal dawk tkun taf il-valencies tal-ligands by heart.
Yes. Yes. But the valencies of the ligands are normally the valencies of the ions. So for chloride, Cl minus, you should have known that. But you would have known that since form 3. Ethylene is a molecule. A molecule has no charge. Water is a molecule. A molecule has no charge. Okay?
Yes.
Now, so, amine and aqua. Amine comes first. Apart from that, they are both 3, right? So it will be tri. So this is tri amine, tri aqua, chromium 3. Okay? Triamine, triaqua, chromium 3. And because it has a chloride, it will be chloride. Second one, you have amine and you have chloro. Alphabetical order, the amine comes first, so this will be pentaamine chloro platinum 4.
You write the two ways next to each other.
Yes, because they are different parts of the name. What you don't write is the mono. When it's one, we don't write it.
Oh, okay. Thank you.
Can
Okay?
you not put a hyphen or anything between the amine and the chloro?
No, not even between the chloro and platinum. Even here, it's supposed down. It's one word. It's literally one word. It's one long word. When we do namings for certain compounds, certain complexes, they can become quite complicated. Okay?
Mm.
All right.
Issa. The next one, the groups are ethylene, diamine, and chloro. So the chloro will actually take precedent. Now, when we draw this complex, it's this one here. Can you see it?
بالكم.
بالكلمة فوق البورد هنا. عارف زايرة؟
ايه.
aħjar.
Ija.
So, this is what we understand by a bidentate liquid. The same molecule, that's one molecule, it has two interactions with the central ion. Okay, the same molecule, it is the interactions between, it has two interactions with the central atom or central ion. I keep on saying atom or ion because it could be both, ta? But mhux biex ħawwadkom. Mela skużawni waħda. Issa. Ethylene diamine. It's one of the groups that you need to know. Ethylene is when you have ethene, pretty much. Okay? Diamine because you then have the two amine groups at the end. Issa, id-differenza hija di. Issa daw kollu ħankun miktub. Toqgħodux tinkwetaw fuq il-namings. The rules will be given. I will be sending them. But
U kloro fejn jidħol allura mbagħad sa ethylene diamine. Kloro taqsek mbagħad fl-aħħar.
kloro għandek dan għandek ngħid. Forget the chloride fl-aħħar.
U suppost kloro ħadd waħda ma ethyl diamine.
Daj kloro. Issa, ma niktbux daj ethylamine peress li huwa multidentate. Peress li huwa multidentate, tiġi biss ethylene diamine platinum 4 chloride. So, mela, peress li huwa multidentate, okay? Ma niktbux daj imma jiġi biss. Okay? Now, sissa miegħi?
Ġifieri biss għal meta jkollok tnej biss, jew
Biss u jkollok tnejn u ikun multidentate.
jkollok tlieta pereżempju.
Hawnhekk qed jgħidlek li għandek tnejn and this is multidentate.
Kif taf li multidentate sir?
You would need to know what the ligands are, but when I drew it, you can see that the same molecule, this is one molecule, right?
Which one? Sorry.
The one. It has two connections, 1 and 2, with the platinum.
Alright.
So it is multidentate. Multidentate means it is sharing two lone pairs with the central atom. And this is sharing two lone pairs. It's sharing one from this nitrogen and one from this. Okay? Now, how do you feel? Do you feel pros in this?
Ser il-klorin, għalak tibta l-ewwel.
Għax chlorine, C comes before E. So alphabetical order, C, you write it first.
Ġifieri bl-alphabetical order, mhux kont kif ikunu fl-order.
The alphabetical order.
Right.
Issa biex tiktbu hemmhekk. The rule is għalkemm sofejna fina u sofejna fina qatt ma rajta, okay, fl-eżamijiet tagħkom, Imma regola l-ewwel tikteb il-neutral ligand, then you write the charged anions. So
Same.
first bil-neutral and then the charged ligands. Yes?
Bil-molecule kif pinġejtu inti meta kont qed tispjega li hux multidentate.
Uh-huh.
Hemmhekk mhux 2 bonds biss għandu. 1 u 2.
Yes, so it's bidentate. What does multi mean? Multi is more than one.
Inti mhux żewġ maċ li hemm monodentate, bidentate u mbagħad multidentate bħala xi ħaġa oħra.
Mela. Monodentate is one.
All right, okay.
Bi is two. And then
Basically, anything above 1
anything above one can also be described as multidentate. Ma jfissirx.
Għax jibsib li per esempio above tridentate biss
Le. Above one. Imma kollha għandhom in-name l-isem tagħhom. You can name anything with mono, bi, tri, tetra, penta, hexa, dentate.
Okay.
But anything above one is also multidentate.
All right.
Okay? Anka Xenia, by the way. Okay? Now, I will be giving you a worksheet. I will be sending it later on in the day. This worksheet will have 10 questions with regards to 10 questions with regards to how to name these compounds. Apart from this, I have a video which is similar to what we've done today, but it's around 10 minutes long, and it just discusses naming, okay? So instead of hearing the lesson over and over again to see the parts that you're actually interested in, okay? You can actually listen to that video and it will give you a clear message of how to write these and why and when. Okay? Issa, ask. I mean, last time there were students who asked me to send me emails. Feel free to do so. I tried to answer them within the hour, in fact. Doesn't mean it's always possible, but most of the time, I'm stuck at home. In the next hour, I can answer as many emails as you want. Okay? Now, there. Yes, it's remember the N2C2. I didn't draw the hydrogens. It's NH2, CH2, CH2, NH2. Yes, it is one molecule. Ethylene diamine. This is one molecule, huh? That is one molecule. Okay? Do you have any questions? Do you have any questions?
Sir, li ġejt bej platinum u nitrogen dik double bond jew qed nara ħażin.
Fej.
Fuq il-board.
M1.
Okay.
Okay.
All right, għaxan ngħid double bond u l-oħra single. Okay.
So I'm gonna stop the recording here because we want